My goal is to see if I can get that h to cancel. Can I get the h to go away? Well, how about we just FOIL this out? Do 2 plus h times 2 plus h. I'll do it off camera because it's not, it's, right? You go here, 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 right? Do your FOIL thing. What is it? H squared plus 4h plus, I'm going to write it backwards. I'm going to go 4 plus, what did you say? 4h plus h squared. That's what you would get if you FOILed this out. Combine like terms. All right, that's just the top left, right? Subtract from that what? 4? All of that over h. Okay, good things should happen. 4's go away, right? And now, do you see it? You can factor an h out. Every term on top has an h, so pull that h out. So I'm going to take the top, pull 1h, oh, forgot my limit. Limit, h is going to 0. Okay, and pull the h out. I'm left with 4 plus h, and then over h. The whole point of factoring the h out was so you could now cancel it out. And now let h go to 0. So what happens if h goes to 0? You get 4. Was that the answer we had before? Yes. And if there's any justice in the world, we should get the same answers, right? Like either way, we should get the same result. We get the same result, right? Now, if you ask me which one of those I think was easier, I think the way we did it the first time was better. Only because it was just a difference of squares and then we canceled and we were done. Here, I had to expand, right? I had to expand this and then get rid of the 4's and then pull an h out. So I would argue that this was actually a little worse than the other way. But the good news is we get the same answer. All right. How about, let's not do the square root one. Let's do this one. Remember this one? Right? We did that, right? And we did this at, find the slope of the tangent line where? It was at x equals 1, wasn't it? Okay, let's use the second definition for this. So the second definition is the slope of the tangent line should be equal to the limit as h goes to 0. I'm just writing the definition out. F of a plus h minus f of a all over h. That's just the definition, right? That definition, both these definitions, right, both of them are not on your formula sheets, right? And I'm not real big on having you memorize something because I personally am not a big memorizer. Is that the right word? I don't like to memorize things. My brain doesn't work that well that way. But these two you have to know for the exam. A week from today, you need to know these two formulas. All right? I will give you the freedom to use either one, but you need to know what they are. Right? All right. We're almost through everyone here. Gabriella, how's it going? Good. Are you understanding today? How do you feel about today?
Good. I feel like this one might be a little confusing, but I think I got it.
Okay, so first things first, replace a with what? Where are we?
No, sorry, 1.
A's with 1s. Okay, so limit h goes to 0. All right, we're replacing a's with 1s. H, like that, right? Okay, what is this? This is a little weird, right? You're taking 1 plus h, plugging it into the function. You want to tell me what that becomes?
We'll just have plus h.
So is it, you got to be careful, is it just, we're replacing Aren't we replacing this x right there? Aren't we replacing that with 1 plus h? Right? So this actually goes in right there. So this will be 1 over, what, square root of 1 plus h plus 3, right? And we can put the 1 and the 3 together. That's just to show everyone I'm doing 1 plus h into the function right there. Everyone see that? Yes?
So would you put parentheses over the 1 plus?
You could, but it won't matter because if this is in parentheses, the first thing I would do on the next step would just drop the parentheses because nothing distributes through. It's just being added. All right, you want to keep going?
And then you would do the minus f1,
Okay, and what's f of 1? When we plug 1 in here, what do we get?
2,
1 over 2, right? 1 over 2. And then all of this is over h. Okay, and I hope to get the h to cancel, right? That's what I'm really hoping for, is that h goes away. What did we do? If you look in your notes, what did we have to do here when we did it the other way? Common denominator, and then we also had to do a conjugate. I see the same sort of thing happening here. I don't see us being able to avoid having to get a common denominator and doing a conjugate. So it's looking like this one isn't any better or worse than the previous, but we won't know until we finish it, right? So limit, h goes to 0. All right, moving quicker here through this. I got 2 over 2 there. Here I've got root 4 plus h, root 4 plus h. That's just because I mean, that's what this is, right? The 1 plus 3 is 4, so that's really a 4 plus h there. All right, my new numerator, let's see, who's got my new numerator? Jaden? Jaden? Okay, Jaden. You doing okay today with all this?
Yes.
Okay, so Jaden, you feel like helping me out with the numerator? When I put these two together, what's my new top?
2 minus the square root of 4 plus 8.
2 minus the square root of 4 plus h over, keep going.
2 times the square root of 4 plus 8.
4 plus h, good. 2 times that, and then all of this, Jaden, over
8.
h. Good. Yes? And now the conjugate, right? Because we cannot get an h to go away here. Unfortunately, there's no h. This h is trapped, that h is trapped. Oh, well, this h would never cancel with this one because it's on the bottom, but I need an h on top to go away. So I'm going to come in with a conjugate, and I'll use the same format I did earlier. I'm going to do 2 plus root 4 plus h, 2 plus root 4 plus h. There's my conjugate. I've got to do it on the top and the bottom, like that. I know I've written a lot today. My markers are all dying. Jackson, how are you feeling today? Good? All right. You like enjoying this? Lie to me. Tell me. Yes. Okay. All right. So, foiling this out, how do you feel?
you get
4?
and then minus parentheses
4 plus x. Good. Perfect. And you have to have the parentheses there, right? Have to have the parentheses. So this is going to be conjugate, so you only have to worry about the first ones and the last ones. And the negative and positive is minus, and then the roots kill each other off, but you have to have that in parentheses. And then over, so Jackson, do you want to do anything with the bottom? No, just leave it alone, right? Because ultimately you want the h to go away, not this part. And then all of that still over h. And if you do everything right, you should get something to cancel. Let's see, trying to save myself some room here. This really becomes 4 minus 4 minus h, right? Not 4 minus 4 plus h. 4 minus 4 minus h. The 4's go away. And so that's really just a negative h on top, isn't it? Which is what we were really hoping for. We were hoping for an h on top, because now that h will go away. You'll see it? Now, when I say it goes away, this goes away, right? This goes away. What's still up here? Negative 1. Do not forget that there's a negative 1 up there when you kill that negative h off. So here's where I'm at. I'm going to get through everyone. So I'm not going to tell you where I'm at. Aaron's going to tell me where I'm at. Where's Aaron? Aaron? Okay. Aaron, are you following today? Yeah? Trying? Okay. Did you follow all my cancellation here? What's still on top? Negative 1. Okay. And then on the bottom, what's still here?
I see it was supposed to be in parentheses. Yeah.
Okay, so all that, right? Okay, and that's it, right? That's all that's left? 2 root 4 plus h, parenthesis 2 plus root 4 plus h. And then we don't have a problem anymore, right, Aaron? I mean, we've canceled the h's out. So now we should just be able to let h go to 0. So no more limit. Grant? Here, let h go to 0. What do you get? On top, you've got negative 1, but what do you got down here? 2 times 2, parenthesis 2 plus 2. Okay. So if you let all these h's go to 0, let that go away, let that go away. This will be square root of 4, that's 2. That'll be square root of 4, that's 2. And then just make sure you do your operations correct here. This is going to be a 4, and then 2 times 4, that should be 16. Hey, that's the same answer we had before, negative 1/16. There it is. All right? I don't think I'm going to do any more of these, like with this. I'm not going to do any of the previous examples. I've done 2 of them. You've seen some of the differences. What I'd like to do is one particular problem, all right? I'm going to do a problem where we're going to compare them pretty much like side by side. We're going to take a look at using Formula 1 and Formula 2, and we're going to see if there's a distinctive difference between the two or not. All right, so let's take the function f of x equals, let's see how bad we want to go here. I'll keep it nice. Let's go x to the 4th, x to the 4th power. And let's find the slope of the tangent line at x equals a. So I'm trying to do it arbitrarily, where we have a nice formula for it instead of doing it at a specific number. Man, somebody smells like really good. I don't know what that was. It smells great. What is it? Soda? What? It just smells clean. I don't know what that is, but it smells clean.
It's eucalyptus.
Is it? Oh, is it you?
Yeah.
Okay, it smells good.
Thank you.
Yeah, I'm like, oh, this is going to be fun. All right, so let's try it with the first definition, right? It's going to be the limit x approaches a, f of x minus f of a over x minus a. That's the first definition. Let me go ahead and write the second definition over here. It's the limit h goes to 0, f of a plus h minus f of a all over h. So those are my 2 choices in terms of limits, right? Over here, limit x approaches a. we're almost done with everyone on my list here. Stephanie? Okay, you're up. So what is this for us here?
The
X to the fourth power, okay? And now what happens if you plug a into that function?
you get
A to the fourth, okay? And then over just this, right? X minus a. Okay. That's what this is turning into, right? Let's go over here. I hate jumping back and forth, but I mean, we're kind of going like comparing one next to the other. This one, let's see. Jorge? All right. You doing all right today? Yeah. Okay. What is this for us? A plus h into that function would be?
Would be a plus h squared.
Yeah,
I mean,
h,
to the fourth.
a plus h to the fourth, right? A plus h to the fourth power. And then minus, what's f of a? A to the fourth as well, right? So a to the fourth. And then that's all over h. All right, now looking at those two side by side and trying to compare which one of those looks nicer to you, who wants to volunteer maybe an approach on this that might work? What's that? Oh, I thought I heard you say something.
yeah, the differences of
Difference of force. So we have a formula for difference of squares, don't we? We don't have a formula for difference of fourths. But you could actually use the difference of squares formula here. You could. Do y'all understand? Like, I could look at that as being, I'll do it right here. I'm going to erase it, but isn't a to the fourth, isn't that a squared squared? Oh, sorry, I should do it this way. X squared squared. Isn't this x to the fourth minus a to the fourth? So that is a difference of squares. It's what goes here? X squared. You do it either way. I like to do plus first. Plus a squared, and then this one becomes the x squared minus a squared. So you could look at it as a different squares, couldn't you? Let me go ahead and do that. Limit x approaches a. This becomes x squared plus a squared, and then x squared minus a squared. All of that over x minus a. Did that help at all?
Do the difference of squares on the second one.
You can do the difference of squares a second time on this one. And this would become x plus a, x minus a, and then they would cancel. All right? So I'm going to run out of room, so I'm going to move up top and do it up here. So this would become limit x approaches a. We have x squared plus a squared. Then we had this one, which became x plus a, x minus a. And then all of that over x minus a, like that. So it's a difference of squares twice, isn't it? And then these go away. And once those go away, I should be able to take the limit. Let me see if I can squeeze the answer in here. No more limit, right? I'm going to let all my x's go to a's. So I have right here a squared plus a squared. And then here I have a plus a. A squared plus a squared is 2a squared times, now a plus a is 2a. And at the end of this, 2 times 2 is 4, and a squared times a is a cubed, and you get 4a cubed. Anybody have a question on that? So here is the formula. Here was what we had. I did a difference of squares, and then a second difference of squares, canceled the factor, replaced all the x's with a's, and it turned out to be 4a cubed. I don't know. What do y'all think of that algebra? Is this crazy or? Let's see. We stopped over here on the second version. Let's see what kind of algebra we can need here. You could do a difference of squares here, couldn't you? But I could also figure out what a plus h to the fourth power is.
Oh, yeah.
Couldn't I? I mean, I'm not saying we couldn't do difference of squares. I agree we could. But couldn't I also do, I'm going to leave that answer up there. Couldn't I also do a plus h to the fourth power, which is a plus h times a plus h times a plus h times a plus h? I mean, I could if I wanted to torture myself enough. I could do that, couldn't I? Does anyone know what that is? You do?
A to the fourth power
A to the fourth
plus 4ha cubed.
4,
Ha cubed.
can I do it the other way around? A cubed h, is that all right?
Yeah, because it passed.
Plus
6a squared h squared
6a squared h squared
plus 4ah
4ah cubed
plus h to the power 4.
plus h to the power of 4. What the hell? How'd you get that? You did? Oh, you did it already.
Now I was doing it
You worked it out? Oh, okay, good.
The Pascal's triangle where you
Yeah,
have 4 through 2.
that's why I thought you did it using a shortcut. There's a shortcut for getting this. And I want to talk about it because we're going to need it in next class probably. So obviously, you did some work, right? You had to like expand everything out. You got that. That's actually correct, so good job. There's an easy way to get this, easier way to get it than to do it by hand, all right? So I'd like to show that to all of you after I finish the problem, all right? I'm going to finish this first. So if you believe that that's true, then this becomes limit h goes to 0. I'm going to write all that out. A to the fourth plus 4a cubed h plus 6a squared h squared plus 4ah cubed plus h to the fourth. That's everything here. That's that top left corner. Minus what? A to the third. And then a to the fourth. Sorry. My fault. A to the fourth. And then all over h. What's going on with my voice? Those two go away. It doesn't seem like much happened there, right? Those two went away, big deal. But what do all of these have in common? An h, right? Every one of these terms still has an h. So you can pull GCF and then cancel the h down here, which I'm going to do on the next line. So equals limit h goes to 0. Okay, I pull an h out of the top. I'm left with 4a cubed, that's what happens when I pull the h out of this, plus 6ah, I still have 6a squared h, because I pulled an h from here, plus 4ah what? Squared, because I pulled one of those, and then my very last term, h to the third, all over h. Right, so an h came out of each one of these, GCF. These are gone.
And now you substitute the 0 for h.
Now you let h go to 0. What happens if you let h go to 0 in this expression? That is gone, right? Because 0 times anything is gone. And then this one is also gone because it has an h in there. And this one is gone because it has an h. The only thing left is what? 4a cubed. Same answer, right? Same answer. Which one do you think was better? Did you like the one where we did the difference of squares twice and got that? Or did you like this expanding that we actually didn't do, right? Someone else did that for us. What was your name again? Nicholas did that, right? Thank you, Nicholas. And then we went and just used that work, right? So I agree that this first way was probably cleaner. But the problem is, if I were to make this, the original problem, had it been x to the fifth, not x to the fourth, you wouldn't have difference of squares anymore. But what you would have over here is a plus h to the fifth. And that you could expand out. And this would work and that wouldn't work. So there are pros and cons. So I need us to understand this way for the a plus h to a power. So now I'm going to talk about Pascal's triangle. It's a way that we can figure out powers of a plus h quickly and easily. I know some of you have heard of Pascal's triangle because you just said you saw it before, right? Pascal. So Pascal's triangle, the way it works is this. I'm gonna first start writing some stuff down. You don't have to write all this. I mean, I'm not going to test you on it, but it's good knowledge to have. All right, if I take the expression a plus h and I raise it to the 0 power, what's anything raised to the 0? 1. So this is equal to 1, right? I'm going to put that 1 right here in the middle. You'll see why in a moment. Now, if I write a plus h to the first power, well, what's anything to the first power? Just whatever it was, right? It's itself. Like raising something in the first power is just exactly what it started as. So I'm going to put a plus h, and I'm going to center it right here. A plus h. Now, what's a plus h squared? So to do that, you would have to FOIL, right? FOIL out. Can I just write the answer without showing the work? Most of you have done a plus h squared before? Yeah, yeah. Yes. It turns out to be a squared plus 2ah plus h squared. That's what you would get if you did a plus h times a plus h and FOILed. Now, a plus h to the third power, you would have to do a plus h times a plus h times a plus h and then do all your multiplication through. I'm just going to show you the answer and we're going to start to see a pattern. So you're going to take this answer on faith because we don't necessarily have the time to go through all of this. That's what it is. It's a cubed plus 3a squared h plus 3ah squared plus h cubed. I'll do one more. A plus h to the 4th power. This is a to the 4th. This is the one we just did, right? Plus 4a cubed h plus 6a squared h squared plus 4ah to the 3rd plus h to the 4th. Nicholas got that for us, right? I'll do one more. A plus h to the 5th. So that's a plus h times a plus h times a plus h times a plus h times a plus h. 5 times. Multiply it all together, collect all your like terms. Here's what you would get. A to the 5th plus 5a to the 4th h plus 10a cubed h squared plus 10a squared h cubed plus 5ah to the 4th plus h to the 5th. Now, you were believing me on that, right? You're just taking that on faith. But let's talk about the pattern here, all right? There is a definite pattern in the way things happen. I want you to focus your attention on the power first. This is the 5th power, right? A plus h to the 5th. Look at just the a's. Just the a's. What happens to the a's? A to the 5th, a to the 4th, a to the 3rd, a squared, a, gone. Right? So what's happening to the powers? Coming down, right? What happens to the h's, the powers on the h's? No h's. H to the 1st, h squared, h cubed, h to the 4th, h to the 5th, right? And that's the pattern for every line you look at. You know, go to this one, 2. What happens? A squared, a, gone. No h, h squared. So they just are opposite of each other, right? So if I were to predict what the next line would read, right, a plus h to the 6th, what I would guess is that I would have what, an a to the 6th plus, don't say the number if you know it, some number, right? Some number, right? And then a to the what? 5th power, and now I should have an h, right? And then plus some other number, and then a to the 4th, and then h squared, right? And then plus some other number, and then a to the 3rd, h to the 3rd, Right, do you see that A is coming down, H is coming up? Plus some number, A squared H to the fourth. When am I going to stop? Some number, AH to the fifth. I should stop when my A's are gone and I have H to the sixth power, right? That's when I should stop. And that is correct. This is correct. All right, I'll leave in front here, there's a number in front of the A to the sixth. That is correct in terms of the powers on the A's and the H's. That's fine. The only thing I don't know are the numbers, right? What is that number? What is that number? What is that number? And it seems a little bit mysterious if you've never seen Pascal's triangle. It's a little mysterious as to where those numbers come from. So I want to go back to this triangle that I've drawn, and I want you to look at just the numbers. We have the number 1, the coefficients, right? There's a 1 in front of that and 1 in front of that. There's a 1, there's a 2, there's a 1. There's a 1, there's a 3, there's a 3, there's a 1, right? There's a 1, there's a 4, there's a 6, there's a 4, there's a 1. And I could keep going, right? So Pascal's triangle, I don't know what's going on with my voice. Weird. I'm going to do it off camera, but Pascal's triangle is just this triangle drawn with just the numbers. No variables in there, just numbers. So if I try and draw Pascal's triangle, the very top of the Pascal's triangle is the number 1. And the rule for Pascal's triangle is that as you move down each row, you should have one more number each time you go down a row. So the first row should have one number, the second row should have 2, third row should have 3. The other rule is that the edges of the triangle should always be 1s. Okay, so this row has one number in it, it's 1. The next row should have 2 numbers, and the edges have to be 1s. So it has to be 1 and 1. See, there's no other choice, right? Let me do it right here. I have 1. The next row should be 1, 1. Now the third row should have 3 numbers, and the 2 end ones have to be 1s. And the number in the middle is always just the sum of the 2 numbers above it. So what's 1 plus 1? 2. Okay? How many numbers on the next row? 4. The 2 edges have to be 1 and 1. So that means I need 2 numbers, 1 here and 1 here. How do I get this number? 1 plus 2. 1 plus 2 is 3. And then 2 plus 1 is 3. So 1, 3, 1. Do y'all see it in here? So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. And now to get the next one, you can almost do it here without even looking up there anymore. You have the 1s on the edges, right? What's 1 plus 3? 4. What's 3 plus 3? 6. 3 plus 1? 4. And then the edge is always 1, right? This one right here, our 2 edges were 1, right? And 1 here. And so this number 5 comes from the 4 and the 1. The 10 comes from the 6 and the 4. The 10 comes from the 6 and the 4. The 5 comes from the 4 and the 1. And then the 1 is on the edge. So we should be able to fill this in now, right? It's 1 and 1.